Dear students, the elements after atomic number 92, that is uranium, are known as transuranic elements, and the elements after atomic number 100, that is fermium, they are known as transfermium elements. Element with atomic number 101 is known as mendelevium, with atomic number 102 is known as nobelium, and with atomic number 103 is known as lawrencium. These were named after the famous scientists. But when the elements after element 103, that is lawrencium, was discovered, these elements were simultaneously reported by the scientists of United States and Soviet Union, and they proposed their own names. Now, the different names for the same element, it led to the controversies. To avoid such controversies, then IUPAC decided to give their own name as the rules suggested by IUPAC. IUPAC nomenclature for the elements with atomic number 100 and more than that. Systematic nomenclature directly derived from the atomic number of the element using Latin words for their numbers. IUPAC decided to give the name as per the Latin words. For various digits of the atomic number, the Latin words are written together and "ium" is added at the end. The Latin word roots for the various digits. First of all, for writing the IUPAC name, we have to know the word root for the various digits. For 0, the Latin word is nil, abbreviation is small n. For 1, the Latin word is un, un, abbreviation u. For 2, it is bi, bi, and the abbreviation is b. For 3, it is tri, abbreviation t. 4, the Latin word is quad, abbreviation is q. For the digit 5, the Latin word is pent, the abbreviation is p. 6, the Latin word is hex, abbreviation h. For 7, it is sept, small s is its abbreviation. Digit 8, Latin word oct, abbreviation O. 9, it is n and the abbreviation is E. Now, using the Latin word, we will write the IUPAC name for all those elements with atomic number more than 100. For example, the element with atomic number 101, its systematic name will be un, nil, unium. For 1, un, for 0, it is nil, that is nil. Again for 1, it is un, and then the name ending is by ium. That is, for the atomic number 101, the systematic name as per this IUPAC is un, nil, unium, and the symbol is UNU. The first U is capital and the other alphabets are in small. Next example, atomic number 102. Its systematic name is un, nil, bium. Un, un, for 1, nil, for 0, bi, by, for 2, and the ending of the name by ium, ium, un, nil, bium. The symbol will be UNB. The first alphabet U will be capital and then the next alphabets will be in the small, that is small n and small b. Similarly, element with atomic number 103, its name will be un, nil, trium. Its symbol is UNT, and so on you can write the symbol. Now, I am taking one more example, atomic number 110, that is 110. 1 un, again 1, so again un. For 0, it will be NIL and the ending of the name by IUM. The complete name will be un-nilium. Symbol UUN. 114, one more example, un-quadium. The symbol will be UUQ. So, this way we can write the IUPAC name of the different elements with atomic number more than 100, and it avoided all the controversies. It was accepted by one and all. Now, let me tell you that the periodic table is subdivided into the 4 blocks, the S, P, D and F block, and that is on the basis of the electronic configuration and the last electron entering the valence subshell. Division of the periodic table into S, P, D and F blocks on the basis of the electronic configuration. But before that, let me tell you that the outermost shell is known as the valence shell. The shell inside the valence shell is known as the penultimate shell, and the shell inner to the penultimate shell is known as the anti-penultimate shell. S block, the elements in which the last electron enters the S subshell of the valence shell. Dear students, as we know that the S orbital can accommodate 2 electrons, so in the S block there are 2 groups and they are known as alkali metals and alkaline earth metals. Their valence shell electronic configuration is NS1 to 2. P block, the elements in which the last electron enters the P subshell of their valence shell, and P orbital can accommodate 6 electrons. So, in total there are 6 groups in the P block, that is from group number 13 to 18. The electronic configuration of the P block elements is NS2 NP1 to 6. The S block and the P block, they are together known as the main block elements or the representative elements. D block, the elements in which the last electron enters the D subshell of their valence shell are called D block elements. The D block elements are placed between S and P block. The D block elements are also known as the transition elements. Now, why these elements are known as transition elements? Dear children, the S block elements are metals and the P block elements, they are mainly non-metals. The shifting from the metallic behavior to the non-metallic behavior is through the D block elements, and that is why they have been given name the transition elements. The transition elements electronic configuration is N-1 D 1 to 10 NS 0 to 2, and since the D subshell can accommodate 10 electrons, so there are 10 groups in the D block. F block elements, the elements in which the last electron enters the F subshell of the valence shell. There are 2 series in the F block, the lanthanoids and actinoids. Their electronic configuration is N-2 F 1 to 14 N-D 0 to 1 NS 2. From the slide you can very well see that the orange colored 2 groups are the S block, the blue colored the 6 groups are the P block, the 10 groups that is shown in the green color are D block elements, and at the bottom the 2 series shown in the yellow color are F block elements. So, in total in the periodic table, depending upon the valence shell electronic configuration and in which shell the electron is entering, there are 4 blocks in the periodic table. Most of the elements are metals in the periodic table. The complete S block, the complete D block, they are all metals. The non-metals in the periodic table are lying in the P block. The orange line shows the metalloids. What are metalloids? These are the elements between the metals and the non-metals. They have the properties of both. This line divides metal from the non-metals. These are all metals. You can see very well that S and D block all are metals. And the pink arrows shows that the right hand side of the periodic table has all non-metals. Dear students, I am sure you must have understood the IUPAC nomenclature for all those elements with atomic number more than 100. How IUPAC ended all the controversies and decided to give the names on the basis of the Latin words. And also you must have understood that the periodic table is divided into 4 blocks, that is S, P, D and F, depending upon the last electron entering which subshell. And majority of the elements in the periodic table are metals and they are lying on the left hand side, that is S block and D block. And all the non-metals are lying on the right hand side of the periodic table, that is P block. And there are few metalloids also, which are dividing metals and non-metals.